So good day everyone. So in this video we will be having a hands-on examination. So we'll be going to explore, reprocess, and analyze the certain datasets by applying the hierarchical clustering. So first we'll be going to open the Anaconda Navigator, and we will be going to launch the Jupyter's notebook. Mm, so I already put I already upload the data set here in the Jupyter's folder, and the hierarchical clustering data. So um so we'll be going to open this file. So um so I already input all the data sets to avoid consuming any time to input everything. So first we put import scipy that cluster that hierarchy as sch. Then we put the import matplotlib that pyplot as plt. Next is we import the pandas as pd. So next is we put df is equal to pd read csv, and we input here um, the title of our dataset, the student info for clustering that csv. So so as you can see in this diagram, here is the data set that we input earlier. Then so next is we will be going to reprocess and standardize the data. So we'll be put x is equal to df that select d types include float 64 and integer 64. And next is linkage matrix is equal to sch linkage x method is equal to word metric euclidean. Then we print the x value. So in the next diagram is here is the standardized data. So to explain this, to interpret this diagram, so as you can see in the cluster O, this is the cluster 0. The cluster 0 is it means that it is it includes students that are high high achievers. It means that it has um, their characteristics are they have high GPA, a high study hours, and active and extracurricular activities. So it interprets that in this cluster zero, it represents that these are the students who excel academically and are well rounded. So, um, and in the cluster one, it also called as the average performer students. So, so their characteristics, excuse me. So there are um, moderate and GPA that average in study hours but less um, less involvement in extracurriculars. So the interpretation is that in this cluster A could represent the students who perform adequately but not engage deeply in their studies or activities. And also, and next we'll proceed to the cluster 2. So in this cluster 2, um, it represents the struggling students, like they have the low GPA, the minimal in study hours, and um, passively high absenteeism. So this interprets that this cluster 3 and so on in the cluster 4, it indicates students who are facing challenges academically and could benefit from additional support. So next, um, we'll be going to generate dendrogram. So um, here is the process. So we'll be input um, sch that dendrogram linkage matrix comma no labels is equal to true. Then plt titled will be input dendrogram for the title. So plt x label is grade point average, so the GPA, and the plt y label is the Euclidean distance, and lastly we input plt show. So here is the result. So here are the dendrogram. So so after that, um we will be um we will be going to apply the agglomerative clustering using using the dendrogram. So here, so to input we use from sklearn that cluster, then import agglomerative clustering. HC is equal to agglomerative clustering. So and clusters is equal to none. So to put the distance threshold is it only depends on what they're gonna use, like also depends, um, it is to use greater than 0 but um, lesser than 10,000. So for the Euclidean distance. So for example, so here I put example is 9,000. Then we put the HC fit the value of x. So after HC clusters, so as you can see, the result of the clusters are 2 because it's the number of the Euclidean distance. So 1, so for the 9,000, so here, so it's 1 and 2. That's the Euclidean distance. um so I forgot something. So this data set is, you need to put it before you can put it first here because it is really important, so we could use it for the visualization of the clusters. So now that I've mentioned is after we apply the agglomerative clustering, so we'll be visualize the clusters. So to put it, we use from sklearn cluster import agglomerative clustering, then from sklearn decomposition, so we import PCA HC agglomerative and cluster is equal to 3, then label as fit predicted 0, then so PCA components is equal to 2x PCA point fit transferred x. So you can see in this video that I already input everything. So as the result for the cluster visualization is here. Yes. And so for the analysis, so observe clustering changes. So I think I will give any other examples. So for example, if we put this, if we have 2000 threshold, 2000 threshold, I'm going to delete. Oh, ooh. So never mind. Ay. Hierarical clustering. Oh no. Um, basta naman ako siya. Yeah, I think that's it. So, um, I really apologize because I really, uh, it's really hard for me to explain everything. But I think that's it in my video, and I hope you understand something. So that's it. Thank you and good day, everyone.